to build intelligent automation, but I want to discover deeper insights. Okay, deeper insights on data. What does it mean? When a patient goes to an hospital, I want to, before even admitting the patient to the hospital, I want to know the length of stay of the patient. How long this person can stay in a hospital? Okay, how long this person can stay in the hospital? For example, correct? So we have a solution. Okay, so here what I have actually, there are different functions. So one of the function that I have is the length of stay. Okay, readmission analysis. How long a patient can stay in a hospital? Okay, how long a patient can stay in a hospital? So you can calculate that based on a clinical condition, patient like phys, uh, mental and physical status. Correct? Like this, you can discover deeper using data. Looking at medical X-rays, correct, by patient. Okay, you can see what kind of symptoms and warnings you are seeing. So this is not an intelligent automation. This is a discovery of insights on a data sets, correct? By looking at the medical X-ray, by looking at the lab work, the machine can read and understand, tells the hidden insights. You no need a physician, correct? And of course, I'm not saying to replace, but I'm just telling you that this is what a data science can do. Okay, a data science can go and dig deeper and tell you the readmission rate of a patient, how soon a patient can readmit it. Okay, so these are all live solutions, correct? These are all live solutions. You can see behavioral pattern. You can see behavioral pattern. So the behavioral pattern here, I can select a patient and see how the patient is performing in all the different sources. What is this person writing in Facebook? What is this person writing in a Twitter? What is this person writing in a storyboard, correct? Like this, I can see. So based on the patient behavior, I can tell the risk of this patient. So what is this? This is data science. This is data science. Taking data, going deeper and trying to figure this out, what this person can do. Occupancy, how long this person is going to be admitted at beta occupancy. Okay, discharge, when this person is going to be discharged, correct? When this person is going to be discharged. So all the things what I'm talking about, these are all taking data in a different form, correct? And then trying to figure out what is their insights, hidden insights. Like you see, there's a lot of things. Here I have a medical X-ray. So this is not a table data where I can read a file and tell what it is, correct? So this is a blood work. Okay, this is a medication. This is a actual medical X-ray. This is a lab work, correct? Taking all of them, trying to find out the pattern, trying to find out what is that I could see in the patient. That is what data science. That is what data science. So what I'm trying to say, using artificial intelligence, what are the two things we can do from industry point of view? You can build intelligent automation. You can build data science. Okay, so the advanced analytics or all data analytics falls under data science. Okay, falls under data science, correct? All right, let's move on. Okay, so how do we create artificial intelligence? How do we create intelligent artificially? Please make sure your phone is in mute, please. It disturbs a lot. So how do we create intelligent artificially? So we understood what is artificial intelligence. We understood what we can do with this. We can build an intelligent automation or we can build data science. So how do we create this intelligence? Okay, teach the machine. What it is, you teach the machine. Instead of a human, you do the job. You teach the machine to understand what is there in the medical X-ray, what is there in the blood work, what is there in the medical report. You teach the machine. How do you teach the machine? Train the machine with the data. Train the machine with the data. How do you train the machine? That is when it comes to machine learning, deep learning, computer vision, natural language processing, robotic process automation. So bottom line, what I'm trying to say, to create artificial intelligence, you pick and choose any one of this. Okay, so we can choose any one of this. Either it could be machine learning or a deep learning or a computer vision or natural language processing or robotic process automation. Okay, so these are ways you can create intelligent artificially. To create intelligent artificially, you have to teach the machine. How do you teach the machine? You have to train the machine. You take as a human. Okay, so if you are a computer science faculty, if you are expected to teach medicine, what is that possible? Yes, it is possible, but you have to go for a training. You have to teach. Someone has to teach about medicine. Okay, So you go back and enroll in a medical program and learn everything. So during the learning process, you will get trained. Okay, that's what this is. Teach and train is the key. So instead of teaching the human, now we are teaching the machine. That is the fundamental essence of this slide. Okay. To create intelligent artificially, you have to teach the machine. How do you teach the machine? Train the machine. How do we train the machine? Use the technique that has been underlined. Okay. So what are the technique? Machine learning, deep learning, computer vision, robotic process automation, natural language processing. We will revisit this again so that you can understand what it is. All right. So now, what can we do with artificial intelligence? We talked about high level. I just added one more thing, digital transformation. From industry perspective, when you go to a business user, when you go to industry, okay, what industries expects you? Industry doesn't expect you to talk about statistics, mathematics, probability. We do need that. I'm not saying no to that. We do need this one. But industry expects someone to build intelligent automation, someone to implement data science, someone to do a digital transformation. The core essence of artificial intelligence. Okay, you take a company Uber. It's a fully digital platform. Okay, it's a full digital platform. No matter where you go, you can book a taxi. No matter where you go, you can book your food, whatever food you want to order. Correct? One single platform. It scales at a magnitude anywhere in the world. It's a global level. Correct? So that's a digital platform. To build such platforms, you need artificial intelligence. You need artificial intelligence. Okay, like I said, there could be hundreds of thousands of people talk about AI. Correct? Ignore all. Fundamentally, when you go to business, what is their expectation? Their expectation is using artificial intelligence, build intelligent automation, build data science, or implement digital transformation. That's the expectation. All right. Now let's go a little deeper. So coming to here, we talked about these three. Okay, intelligent automation, data science, digital transformation. How do we implement these three? We need artificial intelligence. How do we implement artificial intelligence? There's a correction I need to make, right? And this is what we talked about. Okay, so to implement artificial intelligence, we need to understand these things. Okay, let's understand this a little better. So tomorrow, Madam is going to talk about machine learning. I just want to give you a high-level view. What exactly each one of this? It's really important. Okay, they're really important for you to understand. Then we can dive each one by itself portion. Okay, each one itself is specialization. Correct? Machine learning, you specialize in machine learning. Deep learning, you specialize in this one. If you have time, you can specialize in both. Okay, so let's understand what is each one. So far, what we talked about what is artificial intelligence, creating intelligence artificially. We talked about what's an intelligence, type of intelligence, human intelligence, emotional intelligence. So that is as a concept you understand. But when you go to industry, what industry is looking for? Industry is looking for an intelligent automation, data science, digital transformation. How do we implement? We need artificial intelligence. How do we implement artificial intelligence? There are 5 pillars: machine learning, deep learning, computer vision, natural language processing, robotic process automation. Okay, so fundamentally, all these 5 are what it is doing. It is using statistical data analysis, data modeling technique, and creates an algorithm. Okay, all 5. It doesn't matter what it is. Okay, all 5 of this uses statistical data analysis, data modeling, and creates an algorithm. When we say algorithm, what is that? In a traditional software engineering world, you write source code. Okay, you write piece of program. So people write C program, people write C++ program, whatever the program they write. Okay. In this world, we don't write such program. Instead, the machine write this one. What do you call? That's called algorithm. That's called algorithm. And that algorithm, it's equivalent to your source code in a traditional world. Okay, in a traditional world, you teach people to write source code, solve problems, build applications, build software, build automation. Here, we don't do that. Instead, the machine creates this one. What does it create? It uses statistical technique, statistical modeling, and creates an algorithm. And that algorithm is nothing but your source code in a traditional software engineering. All right. So when do we use machine learning? And what exactly it means? Correct? Like I said, there is this focused session on tomorrow. I'm not going to talk about type of machine learning and everything. Madam is going to cover. But I just want you to understand, okay? If the problem is simple, okay? The problem is simple. So I have 50 students in my class. Okay, I want to run a simple predictive model which predicts out of all the 50 students, which students going to go like in a top school or get in a an employment opportunity with some company, correct? So I want to run a predictive model which predicts this one. So out of all the students, I want to run a predictive model which predicts the behavior of the students, correct? So based on the symptoms and warnings, how do you predict this person is going to be for the next 3 months, 4 months, 5 months, 6 months? So those are a very simple prediction. So if you are trying to solve a simple problem with a simple data sets, then the good thing is start from machine learning. Okay, start from a machine learning. So in this model, we teach the machine, okay, with the structured and unstructured data sets. Okay, the data could be structured or it could be unstructured, and that is what we are using. It's the problem is simple, data set is simple. That's a good starting point. Use of machine learning. Okay, I'm not saying only this problem. It could be any problem, but we need to see what technique that we have to use. Correct? So I'm just giving a guideline for you to understand to get started. All right. The second is deep learning. The problem is complex and data is very complex. The example that I told you, okay, this model that what we looked at, okay, this model that what we looked at. So here I have an image, okay. So this is an image here. Here I have an image, correct? I have an image, okay. So these are all medical X-rays. So these are all images, correct? And I also have other data sets like a demographic information about a patient, the name of the patient, date of birth. Okay, these are all very structured data. You see here, I have very complex data sets. I have very complex data sets. So these complex data sets, correct, is what I'm talking about. We need different approach. This is not a simple data set. Going out reading in a Facebook, it's not simple. Going out reading about Twitter about this person, what he or she is writing, it's not simple. I'm trying to tell what this person is talking about, correct? That's not easy. Running a predictive model to predict the risk score, it's not easy. Okay, it's not easy. So this is quite complex. If the problem is complex and data set also is complex, then you can go to use deep learning kind of models. Okay, you can use deep learning kind of models. So there's no clearly defined guidelines. We have to understand what are the problems that we are solving and what kind of data we have. Okay, so in the first case, in the machine learning, the model is simple, data is simple, problem is simple. It's easy to solve. Okay, it's easy to solve. At the same time, there's a lot of things you have to teach the machine. Okay, so the teaching itself has become a challenge. So in machine learning, the teaching the machine is simple. In a deep learning, teaching the machine is quite complex. Okay, because we are dealing with large data sets. Okay, the problem comes with the large data sets. Okay, so in this case, I'm talking about predicting length of stay of a patient and a readmission rate. That is not something that I can use machine learning to solve. Why? The problem is complex, the data is complex. So here I can use any kind of things. It could be structure, unstructured, image, whatever the case may be. Correct? That's what this is. The next is computer vision. When do we use computer vision? What exactly it does? Okay. Keep in mind, in all the cases you are training the machine, okay, with the different data sets. In machine learning, structure and unstructured. In deep learning, it could be structure and unstructured, it could be images. Okay, it could be anything. In a computer vision, what I'm trying to figure out, okay, I'm trying to figure out, trying to find out by looking at the diagnosis, disease condition of a patient, by looking at the medical X-ray or a blood work, right? I want to diagnose this one. Read an image, okay? Read an image and try to make a decision or solve anything that comes around that problem, correct? And that kind of a thing, it's computer vision. So computer vision strictly focuses on images, videos, and anything around objects, okay? Anything around objects. For example, you look at a self-driving car. Okay, look at a self-driving car. When a car drives on a constant speed, it sees an image in front of you, then it stops. It sees a red light, it stops. What is a red light? That's basically an image, correct? It sees an image in front of it. Okay, so it could be a dog, or it could be human, or it could be something that like a static object sitting there. So those are all images. So if you want to teach the machine such type of images, then use computer vision kind of model. Okay, so here I'm not talking about solving complex problems. I'm talking about teaching a machine so the machine can understand what is dog, what is cat, what is red light, what is blue light, etc., etc., etc. Okay, and that is what computer vision. You work with images, you work with videos, you work with objects. That is where you come. Okay, all right. Natural language processing. So what does that mean? When do I use this one? If you want to solve a problem more around written and spoken, okay, a language that what you use, written and spoken. So the machine has to understand what you wrote. The machine has to understand what you speak. Okay. So if you are getting into that level of application, that cannot be a computer vision. Okay. So that could be a natural language processing model. Okay. That could be a natural language processing model. So one of the examples that I put here, conversation-based customer engagement. When you walk into a store, a retail store, the system in front of you understands who you are, correct? If you are an existing customer, it greets on your name. If you're a new customer, it gives a generic greeting. Welcome to the store. Good morning, correct? Or it basically tells, welcome Dr. Badmaja. Okay, so how? She's an existing customer. The system knows about it, correct? So here what I'm talking about, natural language processing, okay, which is basically understands and builds the conversation on you. Okay, it understands, builds a conversation on you. So what kind of conversation? Hey, we have a promotion going on. Would you be interested? No, I'm not interested. Okay, so it builds a conversation based on the language you speak. It is not only conversation, it's for both written and spoken. Okay, written and spoken. So what I'm talking about, in natural language processing, the model learns about languages, both written and spoken. In computer vision, the model learns about images, videos, objects. Okay, in robotic process automation, the model learns about the business processes. So what kind of business process we are talking about? Order to cash, record to report, procure to pay. So these are all industry processes. Okay, I'm sure you have heard about a lot of companies talk about RPA. There's a clear difference. An instruction-driven RPA is different. Artificial intelligence-driven RPA is different. I'm not saying a company name. Majority of the company like now, it's all instruction-driven. Okay, they claim that they're using artificial intelligence, but it's not that easy. It's not that easy. So majority of the company are building RPA, very instruction-driven, hard-coded. Only thing, the task is performed without a human. They all think that, like, since the task is performed without a human, they think it's an intelligent automation. Answer is no. So in a real world, it is not a clear distinction of only these 5 we are going to use. It could be combination of anything. In my example that I talked about, time series analysis, correct? Or the conversation-based customer engagement. Okay, this is a conversation-based customer engagement. My first step is I need to understand who's the customer coming in. That's a computer vision. That's a computer vision. So in a real world, it could be combination of all 5, or it could be combination of any 2, or it could be combination of any 3. We don't know that. It all depends on the problem. It's all depends on the problem. But fundamentally, how do you create intelligent artificially? No matter what, it's only this. Okay, only this. If you master this, you are in a good spot. Okay, if you master this, you are in a good spot. So in order to create intelligent artificially, what we need to understand, teach the machine. How do we teach the machine? And that's when this comes into picture. You can use machine learning technique to teach the machine, or you can use deep learning techniques, or you can use computer vision, or you can use natural language processing and robotic process automation. What exactly this means to you? Each one represents the model. Each model has a learning ability and learning pattern. Learning ability, learning pattern. Example, computer vision model learns the images, learns the videos, learns the objects. Natural language processing model learns about the actual written and spoken dialogue. Okay, written language, spoken dialogue. Okay, so like this, each model has its learning ability, learning patterns. Okay, and that is what we should understand. Okay, that is what you have to understand. All right, like I said, it's a high level overview. Each one by itself, it will take 1 or 2 weeks to cover. So tomorrow we are all going to learn from Dr. T.V. Gita, and she's going to cover about machine learning. So I'm going to move on to my next topic. All right. So we got a base level understanding. What is artificial intelligence? How do we implement this one? What kind of model we could build, etc. Now let's take a step back. How does this is going to impact our education? Okay. How does this is an impact to the education? I have a deep passion for education, correct? Like, so that's because I really wanted to contribute to the society and make sure, correct, like, people get the right information, because there's a lot of information out there which I'm not convinced is right. Some of them are good, some of them are okay, but I really wanted to understand, correct, make you understand. There's a huge impact to the education the way we teach, the way we do stuff with this one, right? So what exactly this is going to do? There will be new curriculums. There will be new learning material. The learning will become a global. It doesn't matter where you are, where I am, okay? It's going to be a global learning experience. For sure, it's going to happen. Second, traditionally what we thought, like, the content will be textbook oriented, correct? Content will be very textbook oriented. Okay, you study this, you are done with this. It's really good, no problem. But now it's leading to the next level, very heavy intellectual driven content, correct? Even if it's a specific topic, correct? So we need someone specialized in the topic who can come and deliver those contents, correct? So building content become very rich. If you look at Google, Facebook, Twitter, correct? What is their foundational platform? Content. Okay. What is the foundational platform? It's a content, correct? So Facebook, it's a personalized content for someone, correct? Like, I need a personalized page for me to promote myself, correct? So that means I want to share my things that are going on in my life, things that are going on with my professional, personal, family, etc. That's a platform for Facebook. Okay. You take LinkedIn. So I want to create my own identity. Someone go and look at me. They can understand who am I, what am I doing, correct? What is that? That's a content. So education, in my mind, leading towards very heavy intellectual contents, correct? So traditional way of teaching, I'm not saying no, it may not be very effective. It may not be very effective, correct? So content is going to play a very significant role, and that is my reading, and I could be wrong. Okay, so and the learning is going to be very digital, correct? So when I say digital, that's, I'm not saying like, so textbook is going to be digital, correct? So like how we are learning, it's a very digital learning, correct? It's going to be like that, okay? That's been proven right now because of the COVID-19. So next one is, we all think that we need a physical building, like 100-acre land, like 1,000 buildings, this and that. I don't think that's required anymore, correct? That's been proven also, correct? So people can stay at home, still learn. I know it's not going to be that easy, but that's the culture system that we are going to build in the future. We are going to build in the future. So that's a change, correct? Instead of going to a class, instead of going to a school or a college or a university, how could I do the same thing at my home, correct? So that's what this is all about. The next we talked about, correct? Personalized learning and personalized assessment. In a class of 50 people, correct? All 50 of them treated at the same level, okay? Without their learning ability. Someone could learn fast, someone could learn slow. At the same time, someone learned visual, someone learned problematic, someone learned like more like theory. So there's different way people can learn these things. Right now, all our textbook, everything is treated at the same level. So industry is doing deep research. How do we personalize content based on the learner's learning ability? Okay, if someone learns fast, the content will be different. Someone learns slow, the content will be different. Same for an assessment, correct? So instead of giving everyone the same quiz, the quiz will be created on the fly based on how they're learning. So that's going to be the fundamental difference of personalized learning and personalized assessment. Okay. In terms of like, the current curriculum or things that what we have, it might have much value. I just want to share with you like, what I learned so that you could understand. Correct? I'm not saying we don't need to teach this one, but what the value it's going to bring to them. Correct? So let's understand this a little more, very specific. Okay. So what I'm saying, traditionally, we have been teaching the students for coding, programming. Okay. Coding or programming. But now we are saying, you don't have to code, let the machine code for you. Then what does that mean? So that means the student has to learn something different. Correct? So we have been teaching the students, learn C, learn C++, or Python, whatever the case. Correct? But now I'm saying, you don't need to do that. Instead, the machine can do the same coding, correct? Every model you run, the model creates an algorithm. The algorithm is nothing but your source code, okay? The model creates an algorithm, okay? The underlying thing, what the model does, it creates a pattern to solve a problem, okay? It creates a hypothesis. It creates an algorithm. That algorithm is nothing but your source code. Now we are saying, as a student, you don't have to code. You don't have to learn to code. Instead, the machine can learn. So what does that mean? The student have now learned a new skills. What is the new skill? Teach the machine. Let the machine understands what problem you're solving. Let the machine code for you. Okay. So now the student has to understand, how do we teach a machine? Okay. Instead of me learning and coding, now I need to learn, how do we teach the machine so the machine can learn and understand? Correct? So what does this mean? We as a faculties are in a position to teach the student how the student can teach the machine to learn. Correct? You see how that changes? So that's what it is. Okay. So I just wanted to give some examples so that you could understand. Okay. So how AI changed the education system. Okay. How AI changed the education system. Traditionally, if you go out, someone is graduating from VJIT, they got selected in TCS, Wipro, Infosys, anywhere. So what they do when they go on a project, they expect them to solve these kind of problems. In a problem solving, there are several steps. These are the steps that typically people follow. You give a problem. The problem is build an application which detects, like, which student is going to perform well, which student is not going to perform well, and etc. In that case, they start with creating this kind of functional spec, technical specs, code, test, deploy, and etc. Okay? So now this is a traditional way of doing this one. The problem here, it's a hard-coded business rule. If anything changes, we will run into rebuilding everything. In the AI world, it changed. We don't need a functional spec. So that's basically changed and replaced by feature engineering. You build feature engineering. Understand what is the underlying data sets and extract the hidden insights, the patterns. That's the feature engineering. Technical design. Okay, so this is more for building models, designing models, developing models. Okay, it's a different skill sets. Okay, code. You don't have to code. You build the model. Let the model build for it. Okay, test. It's a model validation. Deploy, model deployment. So I'm just saying, you see what we had thought for the students. Now it's changed. Okay, and these are the skills the student need to learn and understand when they go on a real project. Okay, I'm not talking about learning institutes. If they want to take a job in the space of machine learning, in the space of artificial intelligence, in the space of anything to do with creating intelligent artificially, they must understand all the things. Okay, they must have to understand all the things. Otherwise, you can say I know these things, but you won't be able to solve these problems. Correct? You won't even come close to do anything on this one. Correct? Like I said, the real world is completely different. Okay, the real world is not easy as what we talk. Correct? If you go out and say how many people know machine learning, I'm sure, like, millions of people say I know. But if you give them a problem to solve, I would say 0.1% wouldn't be even confident to solve these problems. Why? That's because the learning is the issue. Okay, that's because the learning is the issue. The students are not taught at that level. The students are not taught at that level. I felt that is a change in the education system. It's going to happen. It will happen. It's going to happen. It will happen. So here, no hard-coded rules. Everything machine learns. Okay, everything machine learns. So this is basically what I'm talking about. Whatever you see here, okay, on the left-hand side, all the things will be replaced, okay, in the future in a different approach. Okay, so you don't have to create a functional design. So that could be something different way. Technical design, different way. Coding, different way. Testing, different approach. Deploy, different approach. So these are the different way we solve problems. And these changes are basically like what I'm talking about, correct? Yeah, change that coming in front of us. And this change starts from education. And this change comes from redesigning our curriculum, looking at deeper way of teaching students than just giving a high level overview, correct? High level overview students won't be, because you don't find right resources, correct? Even if a student comes out, correct? In a traditional way, someone want to become an expert in Oracle, someone was an expert in business processes, correct? So they can go and learn these things. If someone want to come and become an AI expert, understand and solve real world problem, there's not enough resource out there. Even if there's a resource, it's a high level resources or informational, correct? So there are online courses out there. What do you do with by taking the course? Nothing. It's not going to take you anywhere, correct? It's not going to take you anywhere. So there is a need for change in our education in terms of what to teach to students, to make them an expert, to make them a machine learning expert, to make them a data scientist, or to make them an artificial intelligence architect, correct? For that, we have to design curriculum. We have to change the way that we are teaching for the students in terms of curriculum, training material, and actual facilitation, and how this process overall is going to be laid out. That's a question in front of all of us. Okay. All right. I'm just giving you an example. How does it work in the real world? Okay. So in a real world, for example, in a traditional software, if I want to read data from a table, what I do this one. Okay. So I'm going to read the data from a table. Then that's going to tell me what is there. In the AI world, I don't write SQL. Instead, I use a statistical modeling technique. I use K-mean clustering. What does K-mean clustering does? It groups the similarities. Okay. So what does this group by does? It does the same thing. Instead of writing this, I'm writing a K-mean clustering. or I can use KNN. Correct? So these are all different techniques that I could use for train the machine, so the machine can perform the same thing. In both the cases, correct? In both the cases, I use the same data. I solve the same problem. But the approach what I'm taking in a traditional approach, it's a very hard-coded rule. It's a SQL statement. Okay? In the modern world, in the AI world, I'm not using SQL. Instead, I'm using different. Okay? Instead, I'm using different. So what I'm using statistical data analysis technique, which is K-mean clustering. Okay? So what I'm trying to say here, so there is a need to change our curriculum. There's a need to change our curriculum. So this is basically like, coming to a level of looking at what we teach the students and see, is that going to be effective when the student graduates from the campus, okay? So if a student learns about a SQL and the student is going to expect it and code in AI, correct? Yes, we can say that the student can figure this out by themselves, but it's not easy. It is not easy, correct? It is going to be very challenging for them, correct? So writing a SQL is a simple process. At the same time, implementing a K-mean clustering model, it's a big deal. It's a big deal, correct? There's a lot of things involved. So I'm just trying to highlight here, and these are the changes what we need in our educational system based on AI, correct? There's a lot more, but at least just wanted to give you to understand. All right. So there are different type of AI we could build. Okay, there are different type of AI we can build. So what are the different type of? Okay, what you see here right now in industry, narrow intelligence. Where industry wanted to go, general intelligence. After that, super intelligence. Let's a high level understand what it is. Narrow intelligence, a problem that has been solved for. Okay, a narrow intelligence is a problem that's been solved for a specific focused approach. Okay, specific focused approach. Okay, so that means a self-driving car. Okay, a self-driving car. So that just only drives. Okay, that just only drives. It's very narrow focused. Okay, very narrow focused. A recommendation system which is built by Google, it works only for Google. It doesn't work for Amazon. Okay, it's very narrow focused. A conversation-based customer engagement, which is built by IBM, it works for IBM, but doesn't work for other people. Those are all called narrow intelligent. That means whatever you build, if it just solves one problem or a particular problem, or it works for one customer, okay, it is not generic enough. Okay, it is not generic enough. Those are all narrow intelligence. You are building intelligence for your need. Those intelligence are narrow focused. It just solves one problem or one set of things. What industry wanted? A generic intelligence. What does it mean? You build once, it works across the board. Let's take a customer recommendation system. When you go to a retail store, so the system recommends you, these are the things you could buy. Okay. Or when you're on online, the system tells you, these are the things you may be interested in. So that is built specifically for a particular product or a particular company. Like for example, if you go to Amazon, so Amazon tells you, customer who bought this one, they also bought these things. Can I take that model and deploy in Walmart? No. Why? That's not generic enough. Okay, that doesn't understand. Okay, that doesn't understand. So what industry is leading towards? How do we build a generic model? Okay, build once, deploy anywhere. Build once, deploy anywhere. Okay, that is what it is. Generic model. Okay, so generic intelligence. So the next one is super intelligence. Okay, the next one is super intelligence. Okay, 1 second. So what is super intelligence? Correct? In both the cases, either it's a narrow intelligence or a general intelligence, we have to train the machine, we have to teach the machine to understand. In the super intelligence, we don't have to teach the machine. The machine learns and understands through maturity curve over a period of time. Then it takes its own decision. So what I'm trying to tell you, when we talk about creating intelligence artificially, where we are creating intelligence artificially with very narrow focused. In terms of where we wanted to go next, a generic intelligence. That means you build an intelligence once, then it works for everybody. Example, I build a recommendation system for Amazon. I take the same recommendation system and deploy for other companies such as Walmart, Target, or any other company that Reliance Retail, whatever that is, kind, you could deploy. So that is where industry wanted to go as a next intelligent building process. Ultimately, where we want to go. In both the cases, either it's a narrow intelligence or a generic intelligence, we train the machine. In super intelligence, we don't have to train the machine. The machine learns over a maturity curve, okay, on the maturity curve. So that's a high level, okay? So we don't need this one. There are some slides, I'm going to move on. So when you look at from the business side, correct, when you go and solve these problems, correct, what are the real skills that business is looking for, okay? What kind of skill we need to create intelligent artificially? What kind of skills we need to create intelligent artificially? So if you look at in a real world applications, you need a domain knowledge, okay? You really need a domain knowledge. We can't go out and build artificial intelligence, correct? Because we are teaching the machine to solve the problem. That means I should know how to solve the problem. In order for me to solve the problem, I have to understand what problem I'm solving. That's what the business skills, okay? So that's what the business skills. So that is number one, okay? Absolutely critical, okay? Without that, it's impossible. You can say, I know this, but you won't be able to solve problems. Second, okay, all this all matters to build a model. The second, data skills, okay? The second skill that is really required, data skills. So what kind of data skills we are talking about? How do we work with industrial IoT? How do we work with big data? How do we work with the cloud technologies, correct? So those are all become very dominant role, correct? How do we work with videos, images, voice, text, this, that, correct? So those are all become very dominant skills. The next is modeling skills, okay? How do we model a problem, correct? So predicting someone's health condition, health risk, correct? Or how much the oil price is going to drop, okay? Such prediction requires a modeling technique, okay? Requires a modeling technique. So not only that, okay, also building an intelligent automation. That means an automation works by itself, okay? An automation works by itself. So those intelligent automations are built using different modeling skills, okay? Modeling skills, computing skills, okay? So traditionally what we have done, we coded based on certain, like, systems and infrastructure than what we had. So now we have much advanced data processing, okay? Working with images, working with voices, working with videos, working with objects. So that requires a different type of computing power, okay? Distributed computing, in-memory data processing, parallel processing, correct? All these are all very high advanced topics, okay? High high availability, correct? So all these things are, we may have heard about it, but now it become reality. Now it become reality, correct? Now it become reality. So based on my experience, what kind of skills that's required to someone become an expert creating artificial intelligence? Keep in mind, some people think data science is different, artificial intelligence different, machine learning different, correct? You have to understand, okay, the people who don't have much broader vision, understanding, they all think all are different, okay? So everything falls under AI, okay? Everything falls under AI. So when I say data science, you are teaching the machine to discover deeper insights, correct? As a human, you can't do that, okay? As a human, you can't build a predictive model and run it, okay? So for that, I need a machine. I need a machine. So what I'm saying about, if we wanted to implement artificial intelligence, okay, that includes an intelligent automation, digital transformation, data science. These are the skills absolutely critical in a real world, okay? In a real world. So somehow we have to teach the students, all right? So I'm going to skip this one. One last point, then I will go to the industry use cases, okay? So when you go out and talk to customers, when you go out and talk to industry people, what are they looking for? Why they want to go for implementing artificial intelligence, okay? So there could be several needs, people can go for it. But from industry point of view, what industry is looking for? Industry is looking for, these are the 4 key reasons someone to implement artificial intelligence. The number one, productivity. Okay, the number one is the productivity. Number 2, reduced costs. Number 3, increase efficiency. Okay, so obviously when you have this, the revenue will go up, correct? That's not a key factor. That's not a key factor. So when you talk to people, okay, why someone want to implement artificial intelligence? Why they don't want to work with human? Why they want to get rid of a human, correct? So these are the reasons. As a human, our productivity is less. If someone comes 9 o'clock, leaves at 5 o'clock, correct? In between, coffee, this break, that break, right? Like there's so many things, distractions. There's the emotional thing. If someone said bad thing, then you cry, correct? When you cry, you won't be able to perform. Your productivity go down. As a machine, it doesn't care who sells what, correct? You don't care about anything about it, correct? So what I'm saying, the number of reasons why people wanted to go out, implement artificial intelligence, create intelligence artificially, or implement data science, implement intelligent automation, all the things why it happens. The number one reason is increased productivity. Number two, efficiency. Number three, reduce cost. Number four, increased revenue. So these are the reasons business considering going for artificial intelligence. Okay. So how do we see this impact on a global scale? So since these are all coming much rapid level, there are new policies required. Okay, there are new skills required, new operating model, new technology. There are many things that are required. So these are all, I would say, the impact of having artificial intelligence around us. Correct? It could be good, it could be bad, but I'm just saying we have to learn new skills. We have to understand new policies. Correct? So how does it work? Like for example, because of the COVID-19, we are all not going to our day-to-day working place. Correct? Instead, we are at home. So now we are learning from our home. So what is the new policy? Mute your phone. Okay, there could be many things going on in the background, but we want to the new policies. When you want to join an online conference call or online session, you have to mute your phone. That's a new policy. Okay, so how many people used Zoom in the past? There have been a lot of people. But now this becoming a vital tool in order to collaborate and communicate. They're a personal, professional, doesn't matter, correct? They want to use this one. So like this, there will be new policies, new skills, all of those things going to come. Okay, all right. So now I wanted to talk about, okay, this is one of the key things that I want to talk about. How do we apply this in some industry? What are the problems that we could solve? So this could be in a use case for your students. If you want to teach these courses, okay, you can formalize this part of your curriculum. You can teach the students. So without industry connection, if you teach this subject, there's not much to teach. Okay? So that is why everybody says, I know machine learning. Everybody says, I know deep learning. But if you give them a real problem to solve, they don't know where to start. They don't know how to go about it. Correct? I think that's the lacking process. Okay. So we have to understand, correct? As we talked about, the four main skills are business skills, data engineering, model, and computing. So those four skills, it has to be covered by every student, correct? Learned by every student. Then only they will at least understand what is involved in these things. If we teach bits and pieces here and there, they may not be able to understand. So what I'm suggesting, in case if you want to use this part of your teaching process, feel free. So what are the use cases that I have here? It says patient health risk, financial risk, adherence, behavioral pattern, value-based care, pay for performance, readmission rates, discharge rate, okay? The physician performance, like, instead of someone coming and seeing a patient, how well they perform. Financial forecast on clients, fraud detection, case and disease management, life monitoring, fitness monitoring, health monitoring, what exactly, okay? So this is a use case that we built for remotely. How do we monitor a patient? Okay, remotely, how do we monitor a patient? So you have different days to look at how they performed. Okay, you can look at how they performed in each days. Okay, so this is in a device level communication. Okay, this is not deeper insights. This is more for an intelligent automation. You don't have to physically go and look at a patient in a location. So you can select a patient, work here, correct? So you can select a patient. For that patient, you can see their health activity, daily activity, what they're doing. Fitness monitoring, correct? How much activity they're doing at a fitness level. Health monitoring, correct? You can see the patient health monitoring. Okay, blood pressure, this, that, correct? So you don't have to physically go and touch the patient, see this, okay? You can do everything remotely. You can do everything remotely. And based on that, you can calculate the risk score, like how much they're in the risk actually, all the things, factors, correct? So you can build such applications, okay? So this is basically what I'm talking about, correct? In terms of applying this in healthcare, what are the things we do? So these are the things I have done. I'm not saying this is the only thing we can do. So in my life, these are the use cases I built. Okay, lifestyle monitoring, fitness monitoring, health monitoring. What it means? So it's more of an intelligent automation, an automation built on big data, industrial IoT together. Okay, together. So in this one, you don't have to physically go and see a patient. The patient could be in a hospital, or you could be somewhere else. Through your cell phone, you can monitor the patient's behavior, you monitor the health condition, etc. You can make a decision, correct? So these are some of the use cases. As needed, we can dive deep. How does it apply in the retail space, correct? In a retail industry. So when it's a retail industry, company like Reliance Retail, company like Walmart, Target, these kind of companies, correct? So how does it apply? These are some of the use cases that applied in industries, correct? Omni-channel, correct? When a customer comes from multiple channel, they can come buy things from the cell phone or in-store or like third party, or it could be something. What may be the best possible way to sell this product, correct? Predict the best possible channel to sell the product. Where do I give more promotions? Okay, like this, you want to build this one. Market basket, that's what we talked about, recommendations, correct? Someone who bought this product, they also bought other product. Okay. And customer sentiment. When a customer feels bad thing about your product, they go and write about it. They can write in Twitter, they can write in Facebook, wherever they are, correct? They write about it. So how do you understand the customer sentiments and predict that one? Churn. Who's the customers going to churn out from you? Okay, segmentation. How do you group the customers based on their buying pattern, frequency of buying, spending pattern? So you can do all of those things. Brand analytics, location analytics, correct? So in this particular location, what product is going to sell well, what product is not going to sell well, when there could be some potential challenges, issues that can come from this place, correct? So you can do all of those things in this one, correct? Location, inventory tracking. So typically inventory is taken by human, correct? We don't need a human now. So we can place inventory based on the sales, based on the order, based on many different factors. So it's all statistically driven. It's all statistically driven. Shelf splash, correct? So all these things are a different way of looking at customer information and trying to work on it. Either you can build data science or you can do intelligent automation. So data science would be much easier compared to intelligent automation, correct? Data science is more for dig deeper, get to know insights on data. Okay, dig deeper, get to know insights on data. So some of the use cases are intelligent automation. Some of the use cases are data science here. The next one is energy. Okay, so what it is not that a civil engineer has to do architectural design. Need that. It's gone. So a machine can build a building profile. Like a machine can build a building profile. What exactly it means? You give an image of a building of 2,500 square feet. Okay, so if you give if you train a machine with a building of 2,500 square feet, now we want to come up with a new design for the new building that we are going to construct in the same square feet. The machine learns and understands. It comes back and tells how many windows, how many doors, this and that. All of those things the machine can do. So technically what I'm saying, you don't need a civil engineer who create this architecture, who create this drawing, blueprint, correct? So machine learns and understands and tells you a building of this size, only 2 windows and doors. For this one, the energy cost is going to be this much, correct? So it's getting to that level. So using building profile, reduce energy cost, energy efficiency. Okay, energy cost and energy efficiency. So these are the things what we can do in energy side. Okay, building profile, building control system. That means you can automatically control your electricity consumptions. You can turn on your electricity, correct? All the things you can do. Okay, energy efficiency, energy benchmark, energy rate, financial forecast, and etc. All these things can be done. Okay, all right. So this is my last topic. Then I'll be done. Okay. So what I'm trying to say, this is a live use case that I've done for one of the large telecom company. Okay. I'll quickly summarize how does it really work or implemented in the real world. Okay. So what is that we are trying to do? So we are trying to implement 2 things. One is when a customer on a cell phone call, okay, when a customer is on a cell phone call, if the customer is a premium customer, we don't want the call quality to go bad. We don't want the call to be dropped. Okay, so increase the quality of the call, avoid call drops. Okay, that is one problem. Second problem, if you are in a data plan, okay, you have a voice and you have a data plan. your data plan has only 2 GB of data. Let's assume that is per a month. The 2 GB data is per a month. In the month, on the second week, you already gone 1.9 GB. You have 2 more weeks to go. So now you don't have a data in your data plan. Under such circumstances, if the customer is a good customer, create a new plan and promote a different plan and sell the plan to the customer for the 2 weeks. Okay, that is called increase usage. Increase usage. So this solution, what I'm talking about, has a 3 problem to be solved. When you are on a cell phone call, on a live active call, if the quality of the call is dropped because of the location, because of the tower, whatever the case could be, route the call to a different tower and increase the call quality. Increase the call quality, avoid call drops. And third, increase the usage of the cell phone data services. Those are the 3 problems we undertook. Number 1, avoid call drops. Number 2, increase call quality. Number 3, increase the cell phone data usage. How did we implement? It's a framework. Started from problem statement, okay, and the model selection, technology, data, then model. Okay, so if you see here, these are the tasks we performed at a high level. We started with the problem statement. We did what model to be implemented, whether we need a machine learning model or a deep learning model or a computer vision, a robotic process automation, natural language, or combination of different models. That's a model selection. Then once we're done, then we have to select what technology we are going to use. Okay, so are we going to use Google kind of a technology, such as like scikit-learn, TensorFlow, or any other Python, all the things, whatever you name. And there's so many things involved. Correct? It's not that easy. So that's basically the technology selection. Once we understood what kind of data we need, collect, prepare, integrate, make the data available for the model to run. Second, if it's going to implement a machine learning model, that's a supervised or unsupervised, or reinforcement model, we need to know what model that is. Build that model, train the model, test the model, verify whether the model is working, and look up the acceptance, accuracy, correct? Then deploy the model and continue to monitor the model. If the model is not performing, retrain, retest, and redeploy. So this is a process we followed. Okay, this is the process we followed. And this is just an example of the problem that I'm talking about. Okay, so what I talked about, there are 3 problems. I'm just trying to describe one of the problem. So what does this problem talks about? So what this problem tells you, when you are in a 2 GB data plan, on the week 2, you already lost 98% of your data plan, but you have 2 more weeks to go. Under such situation, how do I create a new plan so that you can continue to use your data plan? Okay, so that you can continue to use your data plan. So for that, predict customer usage churn, when and why. Segment the customer based on the population of the churn, okay, and predict the best upselling plan, and predict the and forecast the financials, okay, and prevent call drops and increase the call quality. Okay, so technically, I'm just going to quickly cover. So what did we implement? Usage churn, random forest. Okay, this is just one example I'm giving. There's a lot more involved, correct? Micro segmentation came in clustering. Target marketing upsell, LDA. Okay, financial forecast, logistic regression. You see what I'm doing? I'm trying to map the problem to a model. Okay, I'm trying to map the problem to the model. Okay, whether it could be a machine learning model or deep learning. This is just an example I'm giving. Okay, the real implementation is a lot more involved. Okay, so I'm just giving you an idea. You take a problem and map what model you want. That's the second thing that what we talked about, model selection. Okay, what model you wanted. Okay, so I wanted to have a usage churn. Okay, when I say usage churn, so how much the data this person is using out of 2 GB, how much has been already used? Predict that, correct? So it's not like you're going after used. You have to predict that, correct? Why? In the current rate, you are downloading a lot of videos. Okay, you are watching a lot of videos. You are sending a lot of emails. Under such situations, you predict how much this person is going to consume quickly and like churn out. Okay, that prediction has to be made. So here, if you noticed, okay, here if you noticed, very simple mapping between usage and the random forest. Correct? Usage, the usage churn, random forest. What is usage churn? That's a problem. And it's a random forest. Correct? All right, let's move on. I'm going to skip these things. So I'm going to quickly cover one thing. In order for us to build this one, okay, in order for us to implement this one, it is not just only AI. We have to implement all three. We implemented the big data platform. We implemented industrial IoT. We implemented AI. All has to work together. Okay. So why do we need industrial IoT? To connect to the cell phone devices, read the data that what's going on. We need a device level information. That's industrial IoT. You could imagine, okay, if a company like AT&T or a Verizon or Reliance Jio, correct? If you take what other company it is, correct? If these companies are using this kind of platform, okay, so looking at customers who's making calls and seeing if the customer usage is going to churn out, then sell them as different plan. Like it's a millions of customers. Then you have a big, massive data to be processed. That's why big data. Okay, that's why big data. And the AI is basically all the prediction that what we talked about. Who's going to turn out? When and why? How do we prevent? What's the best possible plan? And what's the financial implication? All these things need to be predicted. That's the model. Okay, that's the AI model. So in order to implement this whole thing, we introduced industrial IoT, we introduced big data, we introduced AI platform, and all of them are on the cloud. All of them are on a cloud platform. So that's a high level technology. So these are all microservices. Okay, I'm not going to go deeper. I'm going to skip this. Okay, how it has been built. Okay, so this is the actual underlying technical infrastructure, the underlying real technical infrastructure. Okay, so building AI is not that easy. Okay, building AI is not that easy. So these are all different technical component that's involved. You see AI model, that's just only one portion. Okay, you see Python and ML library, that's just only one. But before you get there, there's so many different things involved. Okay, all right. So I have given the details here. How does it flows from here? Okay, so in order for us to run this model, we need data. The data came from in a file, or some of the customers were using SAP, and we also have device level data coming from. Correct. So these are the places from where we get data, and the data is flow through. And this is the runtime model running engine where we have run everything. As I said, this itself has a lot more to cover, but I'm just giving you an idea in the real world what is involved. Okay, how it flows. This is my last topic. Okay, I'm going to stop after this. And if you have any question, you can ask me. Okay, if you have any question, you can ask me. All right, so basically, in order for us to achieve this one, we need different data sets. Okay, we need different data sets. So what are the data sets we need? In this example, I need the connection. The moment you connect to a device, correct? You are calling a cell phone or someone's other phone. It goes through a tower, so that's what connects you. So we need the connection information, and then we also need a usage. Okay, usage could be data, voice, or video, or messaging. Okay, so there are other informations which you could think of. Okay, what it is. I'm not going to read through. These data are coming in, some of them are every 60 minutes, every 30 minutes, correct? So in summary, in a day, we process 150 terabytes of data. In a day, we process 150 terabytes of data. So to build artificial intelligence in a real world, this is the amount of data that's required. And that is why we used big data. Okay, that is why we used big data. Otherwise, it could be a simple platform. We could do that. Otherwise, it could be a simple platform. We could do that actually. Okay, so if you look at my previous slide, I told these three has to work together. Okay, these three: industrial IoT, big data, AI. And that is why at the beginning we talked about it's an interdisciplinary study. Okay, we can't just build AI by itself. We can't build AI by itself. To build AI, we need data. Okay, and data could be in any form. Most cases now, data are coming in the form of digital, like devices, like your Apple Watch or any device that wear Fitbit, anything that you do on a fitness level, okay, all of them coming through a device level. So these three has to work together. Okay, these three has to work together. Otherwise, we won't be able to get the real insights on this one. Okay, so that is the reason I just wanted to highlight. In a, in a real world, in a real world, you have massive amount of data to process. I'm not saying we have to learn everything, but at a higher level, we have to tell the students what is involved when they go out and talk about all the things, correct? So why do we need big data? Why do we need industrial IoT? How much amount of data that I'm going to process, correct? So it varies use case by use cases. In my use case, what I'm talking about, avoid call drops, increase call quality, and like increase call usage, correct? Data usage, so not the call, data usage. Those are the three problems. For that, we have all these data sets. Okay, for that we have all the data sets. So again, I'm not trying to tell you that so all the things we have to do here, but we have to tell the students what is involved, at a high level. So this is basically the different tasks that we performed in order to achieve this one. Anyway, it's fine. Okay, I'm going to this one. So what the end product? So it went live. They wanted to have some more things, which is basically they asked us to look at customer insights. Okay, build a recommendation to come, facial recognition, human recognition, image recognition, voice recognition. Correct. Example: when you make a call on a cell phone, correct. So based on your face, voice, image, it understands, and if you have a payment gateway, it opens the payment gateway. Like instead of asking the customer about, tell me your account number, tell me this and that, correct? I understand based on your face, based on your voice, based on how you are interacting, correct? All of those basically used to open the gateway for the customer. So that was the next phase of the project that I was not involved. I'm just telling you. So they'll continue to implement this one. And these are the use cases you can give the students. If any help on this, I should be able to help you. Okay, any help on this one, I should be able to help you. So finally, okay, so where I'm going to stop, this is where I'm going to stop. So tomorrow we're going to focus on machine learning, and Madam is going to talk about in depth, in detail. So let me summarize what I covered today, then I'll give some time for you to ask questions. So what I talked to you today, I talked to you about what is fundamentally artificial intelligence, not from an academic perspective, more of an industry. So in summary, it's nothing but creating intelligence artificially. What kind of intelligence? It could be a human intelligence or it could be an emotional intelligence. Human intelligence, anything a human does. Anything a human does. What a human does, reading, writing, cooking, watching, this, that, everything, whatever human does, such intelligence you can create artificially. But when you look at industry, how does industry is going to consume this artificial intelligence? In three forms: either an intelligent automation, or a data science, or a digital transformation, or a digital transformation. So using artificial intelligence at industry, we can implement intelligent automation, data science, or digital transformation. How do we implement an intelligent automation or a digital transformation or data science? There are 5 core techniques: machine learning, deep learning, computer vision, natural language processing, robotic process automation. If I'm solving simple problem with the simple data sets, I'm happy to train a machine with a simple data sets, then I will go for machine learning. Problem is complex, data set is quite complex. I don't have any way to understand what kind of data it is. Now the machine has to discover it by itself, then I'll go for deep learning. If I want to teach the machine on an image, video, okay, objects, then I'll go for computer vision. If I want the machine to understand about language, written and spoken, then I'll go for natural language processing. If I want the machine to understand, learn about business processes, such as order to cash, procure to pay, record to report, etc., then the machine has to go on robotic process automation. I did tell about it. In industry also, you see a lot of RPA. There's a difference between an instruction-driven RPA, and an intelligent-driven RPA. Instruction-driven, keep your phone on mute. I'm almost done, please. So an instruction-driven RPA is what you see most of the companies out there, and an intelligent-driven RPA industry is trying to do. The last point we talked in the same context, the type of intelligence what we can build. Narrow intelligence, generic intelligence, super intelligence. Narrow, one problem, one solution. Generic, one one problem solves, like, one solution solves many problems, correct? So narrow is one to one, okay? Generic, one to many, one solution for many problems, correct? So example we talked about, a recommendation system which is built for Amazon could also work for other companies such as Walmart, Target and Costco, etc. Okay, so super intelligence, in both narrow and generic intelligence, we have to train the machine. Okay, we have to train the machine. So that's why people say, oh, data is not correct, that is not correct, this is not correct. So how do we overcome training the machine parts? How does the machine by itself understands? Okay, so through a maturity curve. And that's the super intelligence. We are not there yet. That's where we want it to be. That's where we want it to be. Currently, we are building narrow intelligence. The best examples, self-driving autonomous car. The car knows only how to drive. The car doesn't understand anything else beyond. A recommendation system which is built by companies like Google's or Facebook's or anybody, it recommends only for their product and services, not for anybody, everybody. Okay, so that's one to one. So we want to move away and build one model and solves many problems. Okay, regardless of what it is. Okay, so those are the things we talked about it, and we also looked at different industry and use cases. We looked at health, we looked at oil, energy, and we looked at consumers. Okay, and we looked at how that's implemented at a telecom company with the focus of avoid call drops, increase call quality, and increase usage. I just walked you through at a high level. As needed, we can dive deep. Okay, as needed, we can dive deep. Wonderful. So that's all I have to talk today. So basically, this is to give you a foundation. Then next topic will be advanced. It's based on this one. So I wanted to make sure everybody in session has a foundational understanding how it works in industry. Okay. I do understand you all, like, teaching professionals, you understand, you teach, but this is more from an industry perspective. All right. I have time to ask any questions. If you have any questions, please ask me.
So we have a query from Venkata Shiva Prasad. The question is, using AI, how can we predict the value if the data is given? If you have any RNN code.
So it's very simple. First of all, we need to know what the problem or what we're predicting. Okay. So if Mr. Siva Prasad tells me what is that he want to predict, then we can tell everything. Okay. So prediction is not that difficult part. It's easy. The accuracy of the prediction, the confidence level of the prediction is when the data comes into the picture. Okay. For example, I'm trying to predict whether Siva Prasad is going to get promoted or not. I want to predict whether Siva Prasad is going to get increment or not. I want to predict whether Siva Prasad is going to get promoted to HOD. Okay? So these are all simple predictions. In order to do that, I need data again. Okay? How do I implement? I can implement R, I can implement Python, I can use scikit-learn, TensorFlow. There's a lot of different things we do. So the step one, we need to define what problem we are solving. For the problem, what data we need. Then how do we connect these two? That's when the program comes into picture, either R or Python. So once we know, then what model to implement, correct? So this sequence of steps. So in summary, what I'm saying, I'm not clear on the actual question by itself. So if he has any question, he can mail me, I can guide him. But it's very simple to answer this one. It's not an issue. So the prediction side, prediction is not a problem. The model will predict anything. But the accuracy of the prediction, the confidence level of the prediction is what the question. I think I answered the question. I hope so.
Sir, here I have a small query, sir.
Okay.
Sir, do we have any, sir, this is Praveen, sir. So do we have any approaches for the, do we have any straightforward approaches for the algorithm? Suppose if you want to plan, just now you told, right? So for if you want to predict something, So do we have any straightforward approaches for planning?
Uh, when you say straightforward approaches means like, I wanted to know what you mean by straightforward approach. Like, so can you give me
No,
some more
I'm
context?
telling no any approach. So I'm not telling this straightforward approach. So do we
Mhm.
have any approaches for identifying or for a planning, especially for the plan? Suppose you told one example, right? If suppose if I want to do something like this, that. So that means I'm planning to do something, right? So do we have any approach, specific approach to do that, or can we use any algorithms to do that?
So the algorithms based on the problem that you're undertaking, correct? Like, so the approach, for example, the first thing is to define a problem, what problem you're solving.
Okay.
Okay, so that will dictate what model to select. For example, like here you take, I'm telling here, I want to predict the usage on a cell phone 2 GB data plan. Okay, so in the second week of the month, I want to run a predictive model which predicts how long this person can use the 2 GB data. Can this person use for next 1 week or 2 weeks? How long this is going to go? That's a prediction. For that, I'm using a random forest. I'm using a random forest. Can I use LDA for that? I can't. Okay, so that model is not trained, or that model is not meant for predicting usage zone. So this is basically what I'm talking about. The second step, a model selection. Okay, so once you know the problem, then select the right model. So that is basically the approach, I would say. Then rest everything follows, correct? So
Okay.
everything has to start from a problem statement. Everything must have to start from a problem statement. And that is one of the things that I talked about. The mandatory skill that's required. Okay, the mandatory skill that's required. The number one is business skill. Without business skills, if you learn anything, it will become very abstract. It will become very abstract. You may not be even able to understand what you're learning. Seriously, correct? It appears, see, you have to connect everything back to the real value that you're, the real problem that you're solving, correct? So if it is not, then you're just learning some techniques, correct? There's no connection between the real world and this, correct? So I would say the approach should start from defining a problem, what we are talking about. Okay, define the problem that you are trying to solve. Then select a model. Rest everything follows. Technology and everything follows.
Okay, sir. Thank you.
Thank you, sir. I request all the participants, if you have any queries, either you can post it in the chat box or you can mute on and ask question. I repeat, the participants, if you have any query, please unmute yourself and ask question. So there's a question from G. Kalpana. Sir,
Yes, ma'am.
the level of complexity increases from machine learning to robotics automation.
Can you read the question one more time, madam?
The level of complexity increases from machine learning to robotics automation.
So the machine learning is the underlying implementation. Robotics automation, correct? It is just a problem that you're trying to solve. Okay. First of all, not every robot is artificial intelligence. Okay. Not every robot is artificial intelligence. Most of the robot, what you see, it's instruction driven. You give a set of instruction, it performs this one. Go from here to there, it goes. Move this object from here to there, it moves, correct? So without you instructing, the machine has to learn by itself and understand. I see a box in front of me, I want to move the box. So, or I see something in front of me, I want to move this one. So what I'm trying to say, machine learning is an implementation. Robotic process, correct? A robot, how it performs, what it does, correct? So that is the problem you're trying to solve. Okay, that is the problem in solving. There are two approaches. One is an instruction-driven approach that doesn't need AI. That doesn't need an AI. Second approach is self-learning approach. The robot self-learns by itself, which is very difficult to implement. Which is very difficult to implement, and that is when machine learning comes into picture. You don't have to teach, correct? You don't have to tell what to do. The robot learns from the instruction, the underlying data structure. and then it takes its own decisions. So that is what an intelligent driven robot, and that needs machine learning. Implementing that, it's quite complex. Is that clear?
Hello.
Thank you.
Yes.
Here the participant
Sir,
Prasad
sir,
is
good morning, sir.
muted.
Yes,
You
sir.
question, sir.
Sir, good morning, sir.
Yes, sir.
This is Nagadurga Prasad Reddy from YN College, Narsapur, sir.
Okay, sir.
Sir, give the difference between AI and machine learning, sir.
Okay, so again, I'm telling you,
Sir.
AI is nothing but a concept, correct? What is, read the word. One second, read the word. It's artificial intelligence, correct?
Okay, sir.
What does that mean? You create intelligent artificially, that's all it tells you.
Okay, sir.
Okay, that's all it tells you. You create intelligent artificially. Now the question is, how do I create intelligent artificially? Then you need machine learning. Okay.
Machine learning.
So yes, that is the industry perception. If you read all the blog, people will write completely, I wouldn't say inaccurate. Most of them are written inaccurate.
Sir.
Artificial
Sir.
intelligence, by definition, nothing but creating intelligence artificially. What kind of intelligence? Anything that a human does, those are all intelligence. You create that artificially. How do you create? How do you create? That's when machine learning, you need machine learning. So if you look at my slides, what I talked about,
Sir.
one second. So if you look at what I talked about, okay. So how do I implement, like, if you see here, how do I implement intelligent automation, data science, digital transformation? Those are all the real need from industry on artificial intelligence. For that, we need artificial intelligence. How do we implement artificial intelligence? Correct. So I have to add here.
Okay, sir.
Thank you, sir. There's another
sir. Thank you.
From Dr. Roy. What are the main challenges of ML?
What are the
main challenges of ML?
So the main challenges, I would say, number one, data, correct? Getting all the data sets together and making the data available to the model to run. That's one thing. Second, mapping the selecting the right model for a given problem, correct? So those are the two things. When it comes to data, that also involves training the model and then testing the model, deploying the model. That's all part of the process, correct? So I would not say it's a challenging. It's based on the problem, correct? If the problem is simple, if you look at a lot of YouTube videos, they will say predict whether it's a male or female, predict whether it's a cat or dog, predict pass or fail. Those are all simple things, correct? So that doesn't require complex model, complex data, time-consuming effort. That's very simple, straightforward. But when you get into real-world problems, correct? When you get into real-world problem, what is the possibility for the customer is going to use this product? Okay, so I have a customer who is using 10 products of mine. I suspect the customer may not use all 10 for the next 3 months. I want to know which product the customer is not going to use. Doing such prediction, correct? That's quite difficult. For that, you have to select the right model. You need the right data sets, then train the model. The whole process changes. So I would say by machine learning itself, it's not difficult. The problem that what you're trying to solve using machine learning makes machine learning difficult. Okay. So as I said, predicting cat or a dog or a male or a female, very simple. Okay. Anybody can do it within the next 10 minutes. But taking what I just told you, that's quite challenging. So the problem dictates how complex the model, how difficult to implement such models. Does that make sense?
Thank you.
Continue.
We have 2 more questions.
Okay.
Can I ask it? Okay.
Yes, please.
So query from Baswaraj D. Is it AI, big data, and IIoT platforms are dependent on each other or not?
It's not dependent on each other. Okay. But only thing what we need to understand, the artificial intelligence requires significant amount of data. Okay. So this artificial intelligence needs the data. Since when you go on a real world, 99.9%, you train the model on a big data platform. Okay. So that means when I want to understand a customer sentiment, what a customer is talking about my product, or what the students are telling about me in the social media, correct? The student goes to social media and talks good things, bad things about a faculty. I want to build that kind of model which tells me this is what they're talking about. In that case, I have to look at what they're doing in Facebook, Twitter, and etc. How do we pull the data? That's when I need a big data. I would not say it's a functional dependency, it's more of a technical dependency. So every real world application of AI needs a big data platform. Why? The data set is very complex. So when do I need IIoT? It's based on the type of problem. The one that I talked about right now, building a model which tells me what students are talking about a faculty, that doesn't need an IoT. But if you look at healthcare, where I can connect to a device such as an Apple Watch or a Fitbit or any other devices, then I need industrial IoT. So it's based on the problem. But as of the platform by itself, there is no real logical need or a connection. Okay. If the problem requires, then we need a big data. If the problem requires, we need industrial IoT. Otherwise, we don't need that.
Thank you, sir. Another question from Madhavi. By seeing
Sure.
the data set, how can we know which algorithm can be applied? We
By
train-
seeing what?
By seeing the data set, how can we know which
No,
algorithm can be applied?
no, that's the wrong way. Okay, the way that how you build the model, it starts from the problem, not from the data sets. Okay, if you see here, selecting model, which is ultimately lead towards building an algorithm. Okay, the model is the one creates an algorithm, not the data. The model learns the pattern in the data sets. So what I'm saying, selection of model which internally creates an algorithm, it's based on the problem, not based on the data. So based on the problem, you identify what data we need. Okay, based on the problem, we identify what data we need. All I'm trying to say, the model selection which lead towards building an algorithm, it's based on the type of problem that you are solving, not based on the data.
Thank you, sir.
Sure.
I greatly appreciate the presentation you gave. It was nothing short of incredibly informative. You kept virtually every member of the audience hanging on your every word and patiently answering all queries. Will you share PPT, sir?
Yes, I will send you the PPT.
Thank you, sir. I now request Dr. B. Vijayakumar, sir, head of the CSC department, to speak a few words on this FDP. Over to you, sir.
Thank you, Divya. Good afternoon, all the participants, and Mr. Jyoti Periyaswamy for your valuable and very informative session that is held today. That is first day of our FDP, that is artificial intelligence applied in real world applications. So you gave the insights of how and where you can apply artificial intelligence in the present day. Thank you, Periyaswamy sir. And I'm sorry, morning we could not conduct that inaugural session due to important and urgent meeting by our management. And today we new director have joined in Vidyajyoti Institute of Technology, Dr. Sai Baba Reddy, who held various important posts in JNTU Hyderabad. And so due to that, we could not address you people. And I welcome all the participants to this online FDP on artificial intelligence and data engineering. During this lockdown period, because of COVID-19, we all are busy taking online classes and doing a lot of certifications, planning for future online classes, etc. Also, this is the time we should rejuvenate ourselves with the learning of most emerging science today, which is artificial intelligence. This FDP is organized in four days with a daily one session. So today we had a session on artificial intelligence applied in real world applications, and day two we have machine learning applied, and time series data analysis using machine learning predictive analytics in day three. Day four we have role of data engineering in artificial intelligence by the eminent speakers, Mr. Jyoti Periyaswamy, co-founder DeepSphere.ai, who who handled today's session, and he will be taking sessions on day three and day four. And Dr. TV Geeta, who is a retired senior professor, CSC, Dean College of Engineering, Gundi, Anna University. She will handle the session on day 2. So this FDP is targeted for the academicians and executives who are in the process of applying AI in their organization or seeking more in-depth skills and knowledge of enterprise AI. The objectives of this FDP is a learning experience for confidently building and development and deployment of AI products and solutions, hands-on in-depth skills, knowledge, and expertise on enterprise AI end-to-end implementation, practicing real-life use cases for CPG, retail, health, oil and gas, and energy, practical problem-solving techniques, tools, methodologies, processes, and an AI implementation framework for industries like small scale, medium scale, and large scale. We are lucky to have these eminent speakers with us to gain the best about artificial intelligence and data engineering. I assure you that at the end of the day, you will be enriched with the insights into artificial intelligence and data engineering, machine learning and deep learning, and so on. So I congratulate all the participants for being part of this FDP. All the best and have the fruitful sessions. Thank you. Thank you very much, Professor Mr. Jyoti Periyaswamy, for your very valuable session today. Thank you very much. Thank you.
Thank you so much. I really appreciate the opportunity. Thank you all. Take care. Bye.
Thank you, sir. Thank you, participants, for your cooperation. Kindly fill the feedback without fail. We'll share you with email or WhatsApp groups. Stay in touch. Stay safe and stay home.
Thank you, ma'am.
Thank you. Bye.
Bye, sir.
Bye, sir.
Bye.
Thank you.
Thank you. Bye.
Thank you.